Greetings and welcome. We're taking a look at page 650 for the second time, but we're looking at a different set of problems. We're talking about hyperbolas. Hyperbolas? Hyperbolas. And it looks like we've got an equation in general form here in problem 19. And looking at this, I know that this is hyperbola because it's got an x squared and a y squared term. The signs of the x squared and y squared terms are different. So it's a positive x squared and a negative y squared, suggesting to me that this must be hyperbolic. Bam. So let's try to put this in standard form. So I'm going to group my x's, x squared plus 6x, there we go, and minus 4y squared minus 8y equals 11. Let's see, for the x, I've got nothing to factor out of it, I guess, because the coefficient was 1. So I can just write, I don't even need the parentheses technically, but I'm going to write them just to get myself in the mentality, in the mindset there. For the y's, that's better. I'll factor out a negative 4, right? The leading coefficient is what I'm kind of taking out of those each time. So I'll have minus 4 parentheses. That'd be y squared plus 2y. Equals 11 blank blank. Right? So, double complete the square. 6 over 2 all squared. 3 over 2, or, oh, sorry, 6 over 2 is 3. 3 squared is 9. Add 9 here. Adding 9 in the world of parentheses was really adding 1 times 9, which was adding 9. Aha. Tricked you there. So I'm going to have to also add 9 on the right-hand side. For the world of y's, let's see, 2 over 2 squared equals 1 squared equals 1. So adding 1 in the world of parentheses was really subtracting 4. So I have to subtract 4 over there. Let's see, so let's fast factor these. So this is going to be x plus 3 all squared minus 4 times y plus 1 all squared equals 20 minus 4, 16. So convenient when they land out to be perfect squares. And I want the equation to be equal to 1, so I'm going to divide everybody by 16. So x plus 3 all squared, I don't know what that was. Over 16 minus y plus 1 squared all over 4 and 16 cross cancel. Bam, 4 equals 1. So here's my standard form. Did they want us to find any information on this? Yeah, they wanted to find all the information and graph it. Wow, hopefully I have enough room for this problem. So, looking at this, which way is it oriented? Horizontal. Because the positive fraction is the x fraction. Bam. The center is at -3, -1, right? The x-coordinate is associated with the x. The y-coordinate is associated with the y, right? The value of a is going to be the square root of the positive fraction's denominator. The square root of 16 is 4. The value of b is the square root of the negative fraction's denominator, so that's 2. The value of c can be found using c squared equals a squared plus b squared in the case of hyperbolas. So I'll get c squared equals 16 plus 4. C is equal to the square root of 20, I believe, which reduces root 4, root 5, 2 roots of 5. I always want to box that, but I'm not going to box it. So let's see, what do I need to know? How about my vertices? The verts are going to be, well, it's horizontally oriented, so I'm going to take the x-coordinate and add and subtract a to that, right, of the center. So that's going to be -3 plus 4 is 1, -1. -3 minus 4 is -7, -1, right? In the case of the foci, we'll do the same direction, right? So I'm going to add it also along the transverse axis. So -3 plus or minus 2 roots of 5, -1. And because those are radicals, you can leave it just like that. And let's figure out the asymptote. Whoa, man, whoa, 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 whoa. The asymptote will be, we'll put this in kind of point slope form, y plus, wait a minute. Have we been doing it y equals? Yeah, okay, okay. All right. I'm already starting to think about another type of point slope form, which is going to relate to the parabolas that we're doing today. It's going to be great. So let's see. It'll be x minus h, so x plus 3, and then plus k, so that'll be minus 1. And the slopes are plus or minus what over what? Well, let's think about this. It's horizontally oriented. So it's kind of like this. So the value of A is that distance, so the value of B is that one. So to find the slope, I'm going up B over A to find my, asymptote. So the slopes are plus or minus B over A. All right, right? Oh, which I guess I could actually write in those numbers, 2/4 or 1/2. So there's the asymptotes. Bless you. So I'm going to giraph this.
Why did the book have the asymptote, the equation different?
What was the book's equation?
It said y plus 1 equals something. I don't know.
Oh, did they do y plus 1? So did they move the -1 to the other side?
Yeah.
Okay. Yeah, that's what I almost just did a moment ago, too. Yeah, it's just a different way of writing it.
Oh, so this would be okay, though?
Yeah.
Okay.
I don't know why, but like I thought that the foci was wrong when I wrote it, but I guess this is right.
Let's see. The center is at -3, 1. Then where were our vertices? 1, -1. Then we'll have -7, -1. The foci, ugh, man, I don't think I can enter math into this. Does it let me? -3 plus. No, I can't do square root of 20. Well, that's all right. I don't quite need it, I don't think. I guess I could find they're not technically co-vertices or anything, but I could do -3, and I could add and subtract b to the y coordinate, so that'd be -3, 1, and -3, -3, I think. So let's see what I've got so far. Yep. Let's see, I can hide those. And I'm gonna, unfortunately, I think.
What's the distance? How do you figure out the distance you go up, like the B? You go up 2 units just like B, like you go over 4A and then up B. You get what I'm saying?
go up from the center.
You go up from the center, but you go up B and over A when it's horizontally.
For the slope of the asymptotes, is that what you're referring to?
Invisible box thing.
Yeah, it'll be up B over A for a horizontal one.
For horizontal.
Yeah, for the other ones, it's up A over B. So, yeah. Let's see. Paste this. Here we go. So, I thought I did plot the center. Well, whatever. The center was at -3, -1. So yeah, I went over A left and right to get my vertices, up and down B to get the co-vertices. I'll draw my little box. I guess I'll do it in orange. Bam, right there. And then I'll draw the diagonals through said box. That was pretty good. Well, I kind of saw that it was a slope of up 2 over 4, so I was going up 2 over 4, and I kind of aimed at another point. So I know it's going to, for instance, pass through this point because it's down 2 over 4, down 2 over 4. That's what I'm kind of doing, visualizing. Oh, a little squabble there, squiggle. So let's graph this. So the vertex is here, and it approaches that asymptote. Nope. Whoop, whoop. Infinitely and never gets there. That's a little pointier than I mean, but you know what I'm saying.
How come I thought that to get the vertices you had to take the square root of c?
No, I don't.
What?
Square root of c.
For yesterday, I'm almost positive that it says vertices is the square root.
No, I don't think so.
Why did I think that?
Let's see. The foci are 2 square roots of 5, which was what the square root of 20. Square root of 20 is going to be somewhere like 4.5.
This.
So 1, 2, 3, 4.5.
What do you know why I wrote this, or is this just me being dumb?
Those were the vertices of a rectangular hyperbola.
Oh.
So that's what that was.
It's rectangular.
Because the equation on that one was xy equals a number.
Okay.
So let's see, there's A, there's C, and then here's the B distance right there, right? So so that's what our hyperbola would look like. Good stuff, good times. Let's see. So let's look at 38. The instructions say, write an equation of the hyperbola that meets the set, each set of conditions. Okay. So the equation of one asymptote is 3x minus 11 equals 2y. Let me actually solve this for y. So I'm going to divide everybody by 2. And that's going to kind of put it in slope-intercept form. So I'll flip it around. Y equals 3 halves x minus 11 halves. So what I want to point out is that the slope of this of this asymptote is 3 halves. Okay, so that's going to be a clue that might help us out later. I'm guessing, I'm hoping. Actually, I haven't even finished reading this problem yet. What am I talking about? I just know that it's a fact that I could find, and it's probably helpful. Let's see it. Hyperbola has a center at 3, -1, so that's good to know. Hey, they just gave us some really good information there. And a vertex. Oh, what? No way. They gave us a vertex too at 5, -1. So, looking at those 2 points, what information are you able to gather from it? How do you know that?
Because the k terms
Yeah, because the x coordinates of those points changed. The vertex and the center are both on the transverse axis. So the transverse axis passes through them, and the x coordinates are different. Yeah, it's horizontal. Right, bam. Lots of explanation for that. Horizontal is not xantal, zontal. Bam, there we go. What other value can we find out from this? The length of A. So A is going to equal the distance between those two. So A is 2.
We just looked at the slope because it's supposed to be b over a for a horizontal.
Ah, that's well. But what if I said that the value of A was like 8? Then this could have just equaled something over 8, and it would reduce to that fraction. But you're right. In this case, it does. It will relate to that in just a moment. So it could be kind of proportional to this, but not necessarily exactly those numbers. So, but that is. I mean, I'm still glad you were looking there. And that's what the fact that he did say that we're going to need next is that he realized this is horizontal. So it's going up b over a for the slopes of the asymptotes. So that means that b over a is equal to 3 halves. Right? So that means b over 2 is equal to 3 halves. And if I solve that, multiplying both sides by 2, I'll get b equals 3. So that's how you can kind of find, that's how that clue came into play right there. And that's really the only benefit that it had for us. I don't really care about the y-intercept of that or whatever. So now that I have that, I could find c, because c squared is equal to a squared plus b squared. And I'll plug in what I know. So c squared is equal to a squared would be 4 plus b squared would be 9. So c squared is equal to 13. C is equal to the square root of 13. All right. Bam, bam, bam. So let's see. let's see, they just want the equation. So I guess technically we didn't even need C, but I just want to point out that we could find it just in case for some reason we wanted to. So let's see, we know that it's horizontal, so the equation that I'm plugging this into is going to have the x fraction positive. Y minus k squared. And I'm going to plug in all my values for h, k, a, b. So I'll have x minus, what was it, 3 something? Yep. Over a was 2, I think we just said, so 2 squared is 4, minus y plus 1, I think. Over b is 3, so that's 9 equals 1. And we found our culprit. Mystery solved. Voila. So that's some stuff about hyperbolas. Hopefully you liked it, our internet friends. All sorts of cool facts that you can gather from that. Bam. Know those equations inside and out. Have a great day.